Scientists like to classify things, and we've already talked about one way of describing matter. We can describe its state as solid, liquid, or gas. We can also describe things as pure substances, elements, compounds, and different types of mixtures. And so this is a little bit like if someone gave you a bucket of Lego bricks, you could sort them in different ways, couldn't you? You could sort them by color, put all the yellow ones over here and all the red ones over there. You could sort them by size, the big ones and the little ones. You could sort them by specific type. Okay, these are all the 2x4s, and these are the 2x2 bricks. You could sort them that way. So there's different ways to categorize things. And so identifying the state is one way to categorize matter, and looking at what it's composed of is another way. So an element, what do we mean by an element? An element is a substance that cannot be broken down into other substances by chemical methods. So we're not going to talk about nuclear chemistry. You can destroy elements. You can change one element into another, but it involves nuclear chemistry, and that's just a completely separate piece of chemistry for us in this class. So we're not going to be doing any nuclear chemistry in lab. We just don't have the that's just way beyond. It's like craziness. So chemical methods, getting back to the Legos. So you're playing with Legos. Can you take a 2x4 brick and break it into 2x2 brick? Can you break up a Lego brick in half with your bare hands? No. Some of the long, skinny pieces you could break, but those smaller ones, there's just no way you could break them. Now, if you took them out to the garage and got a hacksaw, could you cut it in half? Yeah. Okay, so nuclear chemistry is going out to the garage and using a hacksaw or a blowtorch or something. Chemical methods is your hands in the living room. Okay? So elements are like the individual Lego bricks. The bricks would be like atoms. You can't make that atom into anything more simple. So each different kind of Lego brick would be a different type of element. Examples of the elements: iron, aluminum, oxygen, hydrogen. The ones I made you memorize a bunch of them, and we've got 2 periodic tables here. All the elements are listed on the periodic table. There are no elements that are not listed here. So if it's not on there, it's not an element. All the matter in the universe is composed of elements. And that's important. So there's 88 different elements that are naturally occurring. All the guys here with the white, those are artificial. They're man-made. They're so unstable. You can make them, but then they fall apart into other things. So the whole universe is made up of those 88 different types of elements. So there are elements and there are compounds. A compound is a combination of elements. So an element is one type of Lego brick. A compound is where you take 2 or more different types of Lego bricks and you make something out of them. That structure that you make out of the Lego bricks can be taken apart with your hands in the living room, right? Nothing crazy going on there. Compounds can be decomposed. They can be broken down into the elements by chemical methods. We can break water into hydrogen and oxygen using a very simple battery. That's a chemical method. Examples of compounds: water, carbon dioxide, table sugar. Each element has a symbol, and each of these symbols has one capital letter. You notice some of them have one letter, some have 2. Like here's bromine. It's got 2 letters. The first letter is always a capital. If there's a second, it's always lowercase. So if you look at the formula and you see 2 or more capital letters, it's got to be a compound because there's more than one element. Here, we're looking at the elements, iron, aluminum, oxygen. Okay, this says O2. There's only one kind of capital letter there. That's an element. Hydrogen is an element. There's only one kind of atom in there. Compounds always have atoms from different elements, and they're always going to have the same composition. So we've listed here water as H2O. There are always 2 hydrogen atoms for every 1 oxygen atom. Every single water molecule has that same composition. If it has a different composition, it's not a water molecule. Sugar, C12H22O11. There are no sugar molecules that are C12H22O9. It's not sugar anymore, it's something else if you do that. So how many of these are compounds? And at this point, the best way is just look at how many capitals are in its formula. Which of these are compounds? Is H2O compound? Yeah, it's got 2 different capital letters. That means it has 2 different elements. How about N2O4? Compound or element? Compound, because it's got N and O. How about NaOH? Compound. MnO2? Compound. HF? Compound. Okay, so they're all compounds, aren't they? What did I do? So 5 of them are compounds. 1, 2, 3, 4, 5. Yeah, 5. Any questions? Interesting.